Okie dokie, one last one so you can see this again, because who doesn't want to see more partial fraction decomposition? Okay, even the name sucks. Okay, so this one we're going to do is x cubed plus 5x minus 1 is equal to x to the 4th plus 6x squared plus 9. Now, just like before, if they give this to you and it's not reduced, or not factored, sorry, factor it. It's not a quadratic, but it looks like a quadratic, doesn't it? It does factor, it's just that instead of x's out front, it's got x squareds out front, right? And that makes the x to the 4th. Now, the two numbers that multiply to be 9 are 3 and 3, and they both need to be plus to get us that plus 6 in the middle. So we've got down to these two little factors, which don't go any further, do they? So we're good at this point, but what I want you to notice again is they're the same, so this would actually look like this. Okay, so there is our denominator with that little squared thing going on. Now there's another little issue here. Because this doesn't factor down to just a nice x plus c binomial, it means that the top of this one needs to look like this. Ax plus b over x cubed plus 3, and the top of the second one needs to be cx plus d over x squared plus 3 squared. Okay. All right, so this one is definitely bigger and uglier, but there's one nice thing about it, and the nice thing about it is that the common denominator is x squared plus 3 squared, so that guy is good to go. We don't have to do anything special. This guy just needs another x squared plus 3. So we're going to go x squared plus 3 up top there. So we do have to FOIL that out. So it'll be, let's see, we'll have ax cubed plus bx squared plus 3ax plus 3b, right? That's what we'll have there. And then plus cx plus d from this fraction, and then the denominator just looks like x squared plus 3 squared. Okay, so there we go with our numerator. Now, just like we did before, we're gonna line up all of the x terms with each other. This one is a little bit ugly, or actually it's actually supposed to be prettier, but it ends up looking a little bit ugly because there's nobody that goes with the ax squared. So we're gonna go x cubed, ax cubed. And there's nobody that goes with the x squareds, so that's just gonna be bx squared. Now, there is this guy and this guy for the x's, so I'm gonna write that as 3ax, but then I'm gonna write the cx over here. Now, do you see why I'm doing this? I'm putting the a's, the b's, the c's, I'm putting them in order there. Okay, so we've gotten rid of all of this and this guy, so this is the only one we have left, and that's our constant. So there's no a's, there's 3 b's, there's no c's, there's a plus d. Okay. So now if you like, there would be a whole bunch of zeros in here. So here's gonna be a 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. So our matrix is gonna have a bunch of zeros in it, which is kind of nice, makes it easier to plug in. So now we're gonna match these guys to these guys. So the original problem had 1x squared. So we're gonna say equals 1, or sorry, why do I keep saying squared? 1x cubed. There are 0x squareds, right? So this is gonna be 0x squared. There are 5 x's, so we're gonna go 5x. And the constant here is -1. Now, because this problem was bigger, I didn't leave myself room down here, so we're gonna have to go with our system or our matrix over here. So our matrix, there's 1A, so 1, and then it's going to be 0, 0, 0, and then that also equals 1. Then the second line is going to be 0, there's 1B, 0, 0, 0. Okay? Then the next one, there are 3 A's, so we're going to put the 3, leave the A and the X off, then 0, 1C, 0, 5. And then the last one will be 0, 3 B's, leave the B off, 0, 1D, equal, oh wait, no equal, sorry, -1, there's our little line going in there. Now this is a big matrix that we have, but with our calculator, it will solve it pretty quick. So one last time, let's go back to our matrix, edit one of our matrices. This one is going to be a 4 by 5. So 4, enter, 5, enter. Now, as we've seen how easy it is to make a mistake, be very careful. 1, 0, 0, 0, 1, 0, 1, 0, 0, 0, 3, 0, 1, 0, 5. Okay, 0, 3, 0, 1, -1. Okay, I think it looks good. Now I'm not trusting myself, but I think it looks good, so I'll quit. We're gonna RREF this guy. Oops, clear, I messed up. I hate it when you mess up. RREF. Matrix, I'm using A. Okay. One, 0, 0, 0, 1, 0, 1, 0, 0, 0, 0, 0, 1, 0, 2, 0, 0, 0, 1, -1. Okay, now remember, the first column is the A's, the B's, the C's, the D's. So this one is that A equals 1, B equals 0, right? C equals 2, and D equals -1. So we're ready to go back up here and say that the A is 1, so it'll just be 1x, and the B was 0, so it's going to be 1x plus 0, which we don't really need to write that, okay, over x squared plus 3, and plus cx, so the c is 2, so 2x, and the d is -1, over x squared plus 3 squared. And now if we want, we can come back and just erase that guy and say that this is x over x squared plus 3 plus 2x minus 1 over x squared plus 3 squared. Alrighty, we got it. Okay, so there are 3. I know that it's a tricky way to do a problem. It's not like you're just like logically this is how you would do it. So I suggest that as you do a couple of these, that you really follow along with the lecture. If you have the lecture there and you push pause and do your problem, look at it, push pause again a couple times until you get the hang of it, because it is kind of a pain in the ass, to be honest. Okay, but definitely practice a couple of them, right? Okie dokie. So, partial fraction decomposition.